All right, we're going to get started on this video. It's for lesson 1-3 practice problems. We are describing transformations of functions. So to get started, the first thing we need to do with any of these problems is check to make sure that we have our x by itself, I guess is the best way to describe that. So what I mean is, like right here, we have 2x minus 8. If you look at our original function that we really need to focus on, it's got a b out front, but then x is by itself inside that inside most parentheses. So we don't quite have that yet, so we need to fix that. We're going to rewrite this as 3f, and it's called factoring it out. So we're going to factor out the 2 so that we have x minus. Now we can't just say minus 8, right? Because if we redistribute the 2, it's 2 times x gets us 2x, but then 2 times 8 doesn't get us a minus 8. So we really need to figure out what number can we multiply 2 by so we get back to where we started with minus 8. So again, you can check that work. 2 times x, 2 times 4, keep your signs correct. And now we can actually look at describing this. So our rules state that the order of operations starts with the most inside parentheses. So let's do that. Inside most parentheses, that's our x minus 4. That is a shift to the right by 4. Again, I'm going to have to shorthand a lot of my writing because the pen I'm using on the screen is not the most precise. So I'm going to shorthand some of my work here today. So we look at the next one. Next one says deal with multiplications. Well, here we have both a 2 times the x and a 3 times the function. So it does not matter which one you describe first, as long as you do them together. So I'll describe the 3 first. The 3 on the outside, again, that's that a out front. That is a vertical, either a stretch or compress. And it is a stretch, vertical stretch, because it's greater than 1. So we're going to call that a vertical. We know it's vertical because it's out front. Three is larger than 1. It's a whole number. It's a big number. So that is a stretch. And we just say it's a stretch by 3. But the next thing we have is actually the 2 on the inside, and that one's a little bit trickier. The one on the inside, we have to be careful because horizontally, and it's hard to grasp this at first. So again, I'm just going to start writing it out. It's horizontal. But when there's a whole number inside describing the horizontal stretch and compress, when that's a big number greater than 1, or if it's negative, it's still a whole number like that. It's not a fraction decimal between -1 and 1. When it's like this, a 2, that is what we consider a compression. Shorthand that, horizontal compression. And again, this is the other part that gets a little tricky to some people, is that we describe it as a compression by the reciprocal. So horizontal compression by 1/2. If that was a 3, we would say horizontal compression by 1/3 or 1/4. If the number inside, if this 2 here would have been, say, 1/3, then we would describe it as a horizontal stretch by 3. Because the number is less than 1, it's a decimal, it's a fraction less than 1. Our descriptor, we take the reciprocal of that and we get the whole number 3. So I'll take a real quick second here. I'll try and describe a little bit. No, you know what? Let's do this. Let's finish this out. The plus 1. Plus 1, if we look at our rules of operation, order of operation says deal with negations and then addition subtractions. Dealing with negations would be like if it was -2x or -3 out front. We don't have that, so we get to skip that step on this problem. The last one is dealing with the adding subtracting, which is the plus 1. And in that case, a plus at the end is a shift up by 1 unit. Again, going back to the horizontal, if I were to take, let's see, I should find room here. Dang, I can only write there. That's not going to work either. Let me draw just over top of this problem, just because I don't have anywhere else to draw. So here's y equals x squared. If you were to translate that, and then the graph ends up looking quote unquote skinnier or taller. So when we look at the transformation from left to right, and we want to look at that from a horizontal perspective, the human nature, the human eye is seeing this thing from the left image to the right image as a compression horizontally. All right, now that's where we get the descriptor horizontal compression. But at the same time, if we were to say, get a graph that visually changed like this from A to B, from left to right, but we needed to describe this from a vertical transformation, we would look at that and actually say that that was a vertical stretch. So visually, if something gets closer together left to right, like this here, we would call that a horizontal compression. But at the same time, instead of describing it horizontally, if we looked at that and it was caused by a number out front, like a 3, we actually look at that as a vertical stretch. So that's where visually we have the same transformation, or close to the same transformation. It goes from wide to narrow, and we describe that in one direction as a compression and in the other vertically as a stretch. So if all you take away from this is that we have a whole number in the inside, it brings things together, that is a horizontal compression. If we have a whole number on the outside, it actually pulls it apart, and we call that a vertical stretch. At the same time, if you have a fraction in the inside, it's a horizontal stretch, because a graph like that would do this. All right, and it would actually pull it apart. So fractions on the inside are horizontal stretches. Fractions on the outside are vertical compressions. Because it also, in a really weird way, you could look at that as almost having pushed down on the top or up from the bottom and squished it, so we still get a vertical compression. That's enough for this problem. That's a lot. In fact, most of you probably tuned out a while ago. But if you are still, thank you for listening, and I'll move on to the other problems, and I will not drone on as much about the transformations for the other problems.